The first section on this review sheet is graphing square root functions, section 11.1. So now remember, when you're graphing a square root function, you want to make a table and plug in numbers so you can take the square root of them. So if we look at number 1, we want to make a table for y equals 1/2 times the square root of x plus 2. So make a table for x, 1/2 square root x plus 2, and y. So since there's just an x inside the square root, I'm going to plug in 0, 1, 4, and 9. And if I plug in 0, the 2 is on the outside, so you want to make sure that you add that last. So first you take the square root of 0, which is 0, multiply it by 1/2, which is still 0, and then add 2, so you get 2. If you plug a 1 inside the square root, the square root of 1 is 1. 1 times 1/2 is 1/2, plus 2 would be 2.5. If we plug in a 4, the square root of 4 is 2. 2 times 1/2 is 1. 1 plus 2 is 3. And if we plug in 9, plug in a 9 and we will get a 3. So if I plug in 9, the square root of 9 is 3. 3 times 1/2 is 1.5. 1.5 plus 2 is 3.5. So now we are ready to graph. So make a graph here, and we need to go all the way out to x on our x-axis, or all the way out to 9. And up to 3.5. So I'm going to make these tick marks kind of big since we need to do some half points. Okay, so my first point is at 0, 2. My next point is at 1, 2.5. It's a little bit bigger. My next point is at 4, 3. And my final point is at 9, 3.5. And remember, when we graph a square root, there is only one arrow, looking like that. All right? We still need to do the domain and the range. So for this one, our x values start at 0 and they go up. So we have x is greater than or equal to 0. And for our range, our y values start at 2 and go up. So y is greater than or equal to 2. Okay, let's zoom back out and go down to our next problem. So for number 2, you can see that we have an x plus 3 inside the square root. So when we make our table, we need to be careful about what x values we plug in. For example, I wouldn't want to plug in the x value 0 because if I plug 0 in for x, I would not be able to take the square root of 3. So you want to plug in an x value that will give you a 0 inside the square root, and that x value is -3. So we have a negative on the outside, and on the inside we're going to put -3 plus 3, which equals 0. Then we're going to take the square root of 0, which is 0, and multiply it by a negative, which is still 0. The next number I plug in, I want to be able to get a 1 inside the square root. So I'm going to plug in a -2. So -2 plus 3 is 1. So we have a 1 inside the square root. The square root of 1 is 1, and then we still need to multiply it by a negative, so we get -1. The next number I want to plug in should give me a 4 inside the square root, so I'm going to plug in a 1. So 1 plus 3 is 4. the square root of 4 is 2, and then we need to multiply it by the negative on the outside. So we get a negative 2. The last number I plug in should give me a 9 on the inside, so I'm going to plug in a 6. So we get the square root of 9, which is 3, and then multiply it by a negative. So we get negative 3. And now I'm ready to graph. Okay, so we have our first point at negative 3 comma 0, so that'll be right here. Our next point is at negative 2, negative 1. Then we have a point at 1, negative 2, and at 6, negative 3. So we have an upside down square root function this time. And our domain is going to be x is greater than or equal to negative 3. And our range is y, and this time our y values are going down, so y is less than or equal to 0. Okay, moving on to simplifying expressions. So this was in section 11.2. So the first expression we're going to simplify is the square root of 50 x to the 7th. Zoom in a little bit more so I have some more room to work. All right, so for these problems, the first thing you want to do is simplify the number inside the radical and then simplify the variable with the exponent. So we're going to break it up as the square root of 50 times the square root of x to the 7th. So now what we want to think about is what are two numbers that multiply to 50, and we want one of those numbers to be a perfect square so we can take a square root of it. So we know that 50 is the same as 25 times 2. So we can break that up as the square root of 25 times the square root of 2, and that will give me 5 root 2. The next thing we want to do is take the square root of x to the 7th, or simplify the square root of x to the 7th. So what we're going to do is divide 7 by 2, and that gives us 3. So we're going to have an x to the 3rd on the outside, and since there's a remainder when we divide 7 by 2, there's an x on the inside of the radical still. Okay? So now we're going to take the 5 in the x cubed, since they're on the outside, and write them together, 5x cubed. And then the 2 and the x stay inside the radical. So this is the simplified answer. Moving on to number 4, we have 4 root 3 plus 11 root 3 minus 5 root 3. Now all of these terms have the same last name, so they're all like terms. So all we need to do is just add and subtract the numbers. So 4 plus 11 is 15. 15 minus 5 is 10. So we have 10 square root 3 as our final answer. For number 5, our numbers do not have the same last name, so we cannot add them together yet. We need to do a little bit of simplifying so they do have the same last name and we can add them together. So I'm going to zoom in a little bit more. There we go. And we need to simplify the square root of 18. So let's think of two numbers that multiply to 18. I can think of 9 times 2. So we want to keep those guys inside the square root. And let's think of two numbers that multiply to 8. That would be 4 times 2. We know the square root of 9 is 3. So now we have 4 times 3. And the 2 is just going to be left inside the square root. And we know the square root of 4 is 2. So after we multiply the numbers, we get 12 root 2 minus 6 root 2. Now the numbers have the same last name, they're like terms, and we can combine them. So 12 root 2 minus 6 root 2 is 6 root 2. All right, moving back over to number 6. We have 8 over the square root of 2y. So, as you remember, we are not allowed to leave square roots in the denominator. So, to get them out of the denominator, what we do is we multiply by the square root of 2y over the square root of 2y. Notice that we have to have two of them, one on the top and one on the bottom. So, in the numerator, we're going to get 8 times the square root of 2y over, and then as you remember, the square root of 2y times the square root of 2y is just regular 2y. Now we're almost done. We have to simplify one last time. Since there is an 8 on the outside and a 2 on the outside, 8 is divisible by 2. So a 4 is going to be in the numerator, and we still have a 2y. And then we just have a regular y in the denominator. Back over to number 7. First thing we want to do when we have a fraction inside the square root is break it up. So we're going to have the square root of 16x to the 4th over the square root of z to the 8th. Now you might want to multiply by the square root of z to the 8th over z to the 8th, but we can actually take the square root of it. First, let's take the square root of the numerator. We know that the square root of 16 is 4, and the square root of x to the 4th, 2 goes into 4 2 times, so we just have an x squared. And 2 goes into 8 4 times, so we just have a z to the 4th. And you're done. You didn't even have to rationalize the denominator for that one. Okay, last problem on this sheet. So for 2 root 5 plus 3 squared, first we need to write it twice and then FOIL. Okay, so when we FOIL, we need to do first. So 2 root 5 times 2 root 5. 2 times 2 is 4. And root 5 times root 5 is a regular 5. And then we want to do 2 root 5 times 3, which will be 6 root 5. And then we have to do 3 times 2 root 5, which is 6 root 5 again. And then finally, 3 times 3 is 9. Now we need to combine some like terms. So first, let's multiply 4 and 5 together and get 20. 6 root 5 plus 6 root 5 is 12 root 5. And we still have the plus 9. And then the last step is we can add 20 and 9 together. So we get 29 plus 12 square root 5.